four different ways of 5 different ways in which we can show organic compounds. The first is called the displayed formula. So we have the displayed formula. Then we have the molecular formula. Then we have the empirical formula. We have the structural formula. And we have the skeletal formula. Now, let's see the displayed formula, how we represent organic compounds using the displayed formula. Let me take an example. This right here, C4H10, like this, all the bonds being displayed. This right here is the displayed formula. So what do we call this? The displayed formula, right? Then we have the molecular formula. What will be the molecular formula? C4H10. This counts basically the number of carbons and hydrogens. So this right here is the molecular formula. And then we have C2H5. So this right here is the empirical formula. So we have the displayed formula, the molecular formula, and the empirical formula, right? Now, let's see the structural formula. What is the structural formula? So taking the same example that I have of C4H10, let's see how we write the structural formula. And it's very important for you to know how to write the structural formula, because most answers need to be given in this form. And you need to understand, you need to know how to write structural formulae in order to understand isomerism. So we have this carbon, it has 3 hydrogens around it. So that would be a CH3. Then you have another carbon with 2 hydrogens around it. So that's a CH2. Then another carbon with 2 hydrogens, that's another CH2. And then you have another carbon with 3 hydrogens around it. So that's a CH3. So this right here, you go carbon by carbon. This carbon with 3 hydrogens, therefore CH3. This carbon with 2 hydrogens, CH2. Then CH2, then CH3. This becomes your structural formula. You can write this also as CH3, and since you have CH2 twice, so you can write it once in a bracket and put a 2 around it like this, and then a CH3. So this is how we write the structural formula. What is the skeletal formula? The skeletal formula is where no carbons or hydrogens are displayed. Like you don't, it shows the outline, the skeletal outline of the organic compound. So the skeletal outline of the organic compound is shown. Yeah. So we do not show. So we do not show the carbons and the hydrogens attached to the carbon. You only show the skeletal outline. For example, you have 4 carbons here and 10 hydrogens. So you don't show the hydrogens. So 1, 2, 3, and 4. So this is a carbon, a carbon, a carbon, and a carbon. The 4 carbons right here, you don't show the hydrogens attached to it. You only show the outline, the skeletal outline, or the carbons. Now this has 1 bond. So the second, third, and fourth would be a hydrogen. This has 2 bonds. So the third and the fourth would be a hydrogen. This has 2 bonds. So the third and the fourth would be a hydrogen. This has 1 bond. So the second, third, and fourth would be a hydrogen. But you don't show the hydrogen, neither do you show the carbons. You only show the skeletal outline, where each corner represents a carbon atom. Yes, you can show it like this, or if you want, you can show it like this, where 1, 2, 3, 4, you have 4 corners. Or if you want, you can show it like this. Yeah, so this right here is how we represent skeletal formulae or the outline, skeletal outline of the organic compound. Now let's see, let's practice some structural formulae, how we'll write the structural formulae. We have the list of these 3 carbon compounds. Let's write the structural formula for these, right? So you have A, where you have a carbon with 3 hydrogens. So this will be CH3, this will be CH2, and then you have another CH3. That's how you write the structural formula. Then B would be a CH2. Then there is a double bond. There's a double bond. So you can show it like this. Yeah. Or you cannot show the double bond. That's also fine, because I'd recommend you do, because then you tend to put extra hydrogens and you don't remember there's a double bond. So it's better to show there's a double bond so you remember and you don't put extra hydrogens, right? So it will be CH2 double bond, CH3. Then this would be CH3, CH2, CH2OH. Then there would be CH3. Now, if you have a side chain with more than 1 atoms, do you see the OH is more than 1 atoms? So if you have a side chain with more than 1 atoms, more than 1 atom in the middle of the molecule, you see this is appearing in the middle. By middle we mean not on the first and the last carbon. The first and the last carbon are called terminal carbons. So if it is not on the first and the last carbon, if it appears in the middle of the molecule, more than 1 atom, then you put it in brackets. So this will become CH bracket OH, CH3. Clear? So if it appears, if a side chain has more than 1 atoms appearing in the middle of the molecule, that is not on the first and the last carbon, you put it in brackets. Now we have E, which is an aldehyde. So it will be a CH3. Then there's a CH2. Now you have a COH. So you will say, oh, COH. But you see here, it confuses you with alcohol, because alcohol is also OH and you've written the aldehyde as also OH. So because this is confusing with alcohols, so instead of writing COH, you will write what? CHO. All right. So the aldehyde will be written as what? CHO instead. Then you have F, which will be CH3, CO, CH3. Then you have G, which would be CH3, CH2, CO2H. Right? You have CO2H, you can write CO2H or you can write COOH, either or is fine. Then you have H, which is CH3, CH2, CN. You can show the triple bond or you cannot show the triple bond, just write CN. Then you have I, which is CH3, CH2, CH2, NH2. Then again, we have an aldehyde. No, we don't have an aldehyde. We have an ester linkage. So how will we write this? So how will we write the ester linkage? Let's see. You have an H. So you write the H. Then you have CO2. So CO2. Then there's a CH2. And then there's a CH3. So H, CO2, CH2, CH3. H, CO2, CH2, CH3. That's how we write the structural formula. Is this clear? So let's go over the structural formulae for these. Let's see. We have CH3, CH2, CH2, CH3. This would be what? This would be CH2. You can show the double bond. CH, CH2, CH3. Part C would be CH3, CH double bond, CH, CH3. D would be CH3, CH2, CH2, CH2OH. Then this will not go in brackets because it's on the last carbon. First and last are called terminals. If you have more than 1 atom side chain attached on those carbons, you do not put in brackets. Now E, the OH appears in the middle of the molecule, so you will put it in a bracket. CH2, CH3. This would be CH3, CH2, CHCl, CH3. The Cl will not go in brackets because it's only one atom. All right. Then you have G, which is CH3, CH2, CO, CH3. H, which is CH3, CH2, CH2, and aldehyde would be written as CHO. Then you have I. This is CHO, right? So this right here is CHO. Then you have CH2, CH2, CH3. Yes. So this is how you write the CHO. Don't write it like this. Don't write it like this. CHO, CH2. No, because then that will imply that the O is bonded to this carbon, which it's not. So don't write it like that. Write it like this. CHO, CH2, CH2, CH3. Clear? Then you have CH3. You have CO2, CH2, CH3. Then you have COOH. So you can write it like this, CO2H. Guys, it's not a mirror image. Please don't write it like this. I mean, please don't write it like this. Don't think that it's a mirror image and write it like this. No, this is CO2H. So it is CO2H. Clear? It's not a mirror image. I've just written it from right to left so that you understand it's not a mirror image. Yeah. And then you have a CH2, a CH2, a CH3. Is this clear? Do you guys understand this? Let's see the structural formulae for these. So I'm going to do them for you, and please, I want you to follow. Let's see. So we have the first one here. So we have the CH3 right here. Then we have CH right here with a double bond. Then you have a CCl. So you have a CH, double bond, CCl. Then you have CH. Now this CH3 is going to be in brackets because you see it's more than one atom and it is in the middle of the molecule. It is not on the first and the last. So you put it in brackets. And then you will have CO2H. Clear? Then number 2 would be CH3, CH, double bond, CCl. Then you have C bracket CH3. Br will not be in brackets because Br is a single atom. And then you will have CHO because of the aldehyde. So CH3, CH, double bond, CCl, C bracket CH3, Br. If you want to write the Br first, then put CH3 in brackets later, that is fine too. All right. And CHO for the aldehyde. Then here, number 3. So you have a CH3, which is this. Then you have C with a CH3 and an I, right? So you can write C bracket CH3 and an I. You can write I first, CH3 later, up to you. And then you have CH2, then you have CO, then you have CH3. Then number 4, you have CHCl. Now, if you want, you can write it like this, then put a double bond, but it seems as if the Cl is attached to this carbon, which it's not. So it's better you write it this way. CHCl, double bond, C bracket CH3, then you have CHCl, and then you have CHO. Yes, for the aldehyde. Then number 5, you have CO2H. Again, you write it from right to left like this. Yes, CO2H, C bracket CH3Cl. Then you have CClBr, whatever you want to write first, Br or Cl, up to you. And then it's an acid again. So that is CO2H. Clear? Then 6 would be CHO. You write it like this and read it this way, CHO for the aldehyde. then you have C bracket CH3 and an I, then you have CHCl, then you have CHO again. Then number 7 would be CH2OH. Do you see CH2OH? Now, if you want, you can write it like this, but then when you write it like this, it seems as if this OH is attached to the next carbon, which it's not. So it's better that you write what? You write it from right to left like this. CH2OH, CHCl, then you have C bracket OH, double bond, then you have CH, then you have CH2OH. Clear? Is this understood? So let's go over this. Number 8. So we have CH2Cl. So you write it like this, CH2Cl. Yeah. So this is CH2Cl. Then we have C bracket CH3, double bond. Then you have CH. Then you have CH bracket OH. Then you have CH2OH. Clear? Number 9 would be CH3, CH2, then another CH2, then you have CO2, and then you have a CH3. You can write the CO2 as COO as well, right? Number 10 would be CH2Br. So again, you write it like this, CH2Br. Yes. So you have CH2Br. Then there is C bracket CH3Cl, and then there is Cn. Number 11 is CH3, Cl, double bond, Cbr, and then you have a CO2H. Number 12 is CH3, then you have a CH2, then you have a Cbr, double bond, C bracket CH3, because this is more than one atom in the middle of the molecule, CH2NH2. The H2 will not go in brackets because it's on the terminal carbon. Yeah. Number 13 would be CH2 double bond, Cbr, then you have CH bracket OH, and then you have CO2H. Number 14 is CH3, C bracket OH twice. Either you write it like this or you write two OHs like this. Either way is fine. So OH twice, then you have CH2, and then you have CO2H. Then you have 15, which is CO2H, then you have CH bracket OH, then you have CBr bracket CH3, and then you have CO2H. Clear? So this is what we have. These are the structural formulas. Now let's see skeletal formulae. So for the skeletal formulae, let's see, we only need to show the skeletal outline, the carbon outline. Do not show the carbons, don't show the hydrogens attached to it. So you have 3 carbons, 1, 2, and 3. Right here we have 3 carbons. So you show it like this. Between carbon 1 and 2, you have a double bond. So you show that like this. Then number 3 would be 1, 2, and 3. And on this carbon, you have an OH. So you will show the OH like this. Yes. And now you'll be like, but miss, you said don't show the H. I said don't show the H attached to the carbon. This H is attached to the oxygen. So you will show that. Then number 4 would be 1, 2, 3. And right here, you will have the OH. You can show it like this. If you want, you can show it like this. If you want, you can show it like this. However you want to show it, you show the OH. Clear? Part 5 would be 1, 2, 3 carbons. And on this carbon, you have a double bond O. So you show a double bond O like this. Yes. Don't show the H here because this H here is attached to the carbon. Don't have to show it. And how do you decipher? How do you read this? How do you decode it? Let's see. So you have 3 carbons. So you have 1, 2, 3. On this one, you have a double bond O. Everything else is hydrogen. This carbon is making one bond, so second, third, and fourth is a hydrogen. This is making two bonds, so third and fourth is a hydrogen. This is making three bonds, the fourth will be a hydrogen. Clear? That's how you read this formula. Number 6, let's see. So you have 3 carbons, and on this you have a double bond O, so you show it like this. G, let's see how you draw that. So 1, 2, 3, and on this carbon you have a double bond O, OH. So you show it like this. You can show it this way. You can show the double bond O, OH like this, up to you. Yes, H would be 1, 2, and 3. 3 carbons, and right here you have a triple bond N. You just show the triple bond N like this. Don't show the carbon. Then here you have 3 carbons, and on this you have NH2. So this becomes NH2. Then J would be H. You have a carbon with a double bond O. So right here you have a double bond O. Then there's a single O. And then there's another carbon. And then there is another carbon. Do you see? You have 1, 2, 3 carbons. And on this you have a double bond O and a single bond O like this. Yes. So this is what J looks like. Do you guys understand this? Do you do, and I'm going to do an example of a skeletal formula for, let's say, this, right? Number 1, I'll have you try the rest of them as homework. So this has 5 carbons. So 1, 2, 3, 4, 5. 1, 2, 3, 4, and 5. Do you see? 1, 2, 3, 4, and 5. You don't have to make them bold either. Between carbon number 4 and 3, you have a double bond. So right here we have a double bond, right? Then on this you have a Cl, so you put a Cl. Then on this you have a CH3. So the CH3 will not be written as CH3. You will just draw a line, because the line shows one end. One end means a carbon, and that will mean the rest of them are hydrogen. And then this one has a double bond O with an OH. So that becomes your skeletal formula for this one. Is this clear? Do you guys understand this?